Welcome, Algebra 2, to the middle of the Chapter 11 study guide video. So we are going to be starting with number 8 today. So number 8 says, use what you know about determinants to solve for x, show all work. So what it's giving you is 155 is giving you the determinant. And so what you just have to do, it's basically just an algebra problem in the end where you have to solve for x and kind of work backwards. So I'm just going to first start by setting it up. So remember, we use our top row. So our top numbers there as the numbers that we're multiplying it by. So 5, and then we set up our determinants. So we cover up the column it's in, and we cover up the row that it's in, and we're left with 4, -4, 7, and 2. And then subtract, because remember, nice signs here. So we have adding, subtracting, and adding. So we subtract x, that's my second number in my row. And then by the determinant, so we cover it up. We cover up that top row, so we're left with 1, 3, 7, 2. And then plus -2, cover up that column and then the top row, and we're left with 1, 3, 4, -4. Okay, so now, oh, and all of that, sorry, is equal to 155. So now what we're going to do is we are going to start multiplying and finding our determinants here. So we start with multiplying, so we'd bring that 5 out, and then it would be 4 times 2, so 8, minus 7 times -4, which is -28, minus x times 1 times 2, which is 2, minus 7 times 3, so 21, minus 2, because positive, negative, 1 times -4, which is -4, and minus 3 times 4, so minus 12, equals 155. So then I just start kind of simplifying it. 8 minus 28 gets me 36, minus x times 2 minus 21, so 2 minus 21 is -19. And then minus 2 minus 4 minus 12 gets me -16, equals 155. And then I'm going to move up here so I have a little bit more room. So 5 times 36 is 180. And then -x times -19 is positive 19x. -2 times -16 gets me positive 32. And then we start by combining like terms. So 180 plus 32 gets me 212. I subtract 212 from both sides, and I get 19x equals -57. Divide both sides by 19, and I get x is equal to -3. If I wanted to check this, I could. All I would have to do to check it is just plug it in to my calculator, but instead of putting x there, I would put -3. And so if I plugged that into my calculator and I got my determinant to be 155, then you know you did it right. So that's an easy way of checking. Okay, so for number 9, it says given the determinants, which shouldn't be determinants, that should be like given the matrices. Who typed this? Anyways, it says given the matrices, solve A times B. So let's do this one nice and slow so I don't mess it up, you don't mess it up, and we finally get how to multiply these. Remember, when we are multiplying, you are multiplying your rows by columns. Okay, so let's check to first see if we can actually multiply. This is a 3 by 2, and this is a 2 by 3. So because this 2 and 2 are the same, that tells me I can multiply these. And my result is going to be a 3 by 3 because of those numbers outside there. Okay, so let's start. So we're multiplying A times C. Okay, so let's get out some colors here. So the first thing we're going to do is we're going to multiply my first row by my first column. So that would be 3 times 4. So 3 times 4. Plus, we're always adding here, negative 4 times 1. Okay, so now I'm going to move down my row. So I'm going to stay here. I'm going to move down my row. So that means I move down my row here, but I'm staying still in column 1, so I'm going to stay still in column 1. So that would be 1 times 4 plus 5 times 1. Okay, and then we'll move down another row again. And so when I move down my row, I move down my row in my matrices, but I stay in column 1. So that would be 5 times 4 plus 2 times 1. And I always check kind of at the end. 4, 4, 4, those line up. 1, 1, 1, those line up. And those should be in my column. Okay, so now if I move over in my column, I'm going to move over in my column in my second one. So I'm going to run out of colors here, but first row, second column would be here. So we would go 3 times negative 3 plus negative 4 times 1. Okay, like I said, I am really going to run out of colors here, so I'm just going to continue on with blue. So at this point, we're going to move down a row. So we're going to move down a row, but stay in column 2. So 1 times negative 3 plus 5 times 1. And then I'm going to move down my row, stay in column 1, so 5 times negative 3 plus 2 times 1. Okay, so now that I've got that column, I can move over a column, so that means I'm going to be in my last column. So I multiply 3 times 0 plus negative 4 times negative 2. I move down a row, I stay in the third column, so I move down my row here, stay in my third column here. So 1 times 0 plus 5 times negative 2, and then 5 times 0 plus 2 times negative 2. Okay, now again, double check. Negative 3, negative 3, negative 3, 1, 1, 1. 0, 0, 0, negative 2, negative 2, negative 2. All my second numbers always are the same in every single column. Okay, so then I start to simplify. So this would be 12 plus negative 4 to get me 8. 4 plus 5 to get me 9. And 20 plus 2 to get me 22. Negative 9 plus negative 4 to get me negative 13. Negative 3 plus 5 to get me 2. Negative 15 plus 2 to get me negative 13. 0 plus 8 to get me 8. 0 plus negative 10, negative 10, and 0 plus negative 4, negative 4. And that does it for that one. Woo! Multiplying done. Okay, so let's move on to solving our systems. So we are going to start on number 10, solve the system graphically and algebraically. So first thing, I have a circle on my first one because x squared plus y squared, and then I have a line. So I'm going to just start by solving it algebraically. What I would like to do, and the method that I would use to solve this, is substitution. If this was an x squared and this was a y squared, then I would use elimination, but because it's x squared and x and y squared and y, I'm going to use substitution. So I'm going to get y all by itself. So I'm going to subtract x from both sides and divide by -1. Okay, so into my equation, my top one, x squared plus y squared equals 36, I am going to plug in x plus 6 wherever there is a y. Okay, so x squared stays the same, plus, but instead of y, it's going to be x plus 6, and then the squared stays the same, and the 36 stays the same. Now remember, x plus 6 squared, that's like saying x plus 6 times x plus 6. So you have to multiply that out. So when you multiply it out, you get x squared plus 12x plus 36 equals 36. Okay, so then I would combine like terms. 2x squared plus 12x plus 36 equals 36. Because I have that x squared, I want to get it so I have this equal to 0. So to get that equal to 0, I'm going to subtract 36 from both sides, and what you should recognize happens is this goes away. And so we're left with 2x squared plus 12x equals 0. And so now I can factor, and it actually makes it really easy to factor because I have a GCF. I factor out a 2x, and I'm left then with x plus 6 equals 0. And so now I have two factors. I can set them both equal to 0 and solve. So x is equal to 0 and x is equal to -6. So now that I have two different x values, I can plug them into my equation to get my two different y values. So when x is equal to 0, y is equal to 0 plus 6, so y is equal to 6. So one of my ordered pairs is going to be 0, 6. The other one is when I plug in -6 for x, so y equals -6 plus 6, so y equals 0, and then I have -6, 0. So that is my answer solving it algebraically. I expect you guys on the test to solve it both ways, algebraically and then show it graphically. So now we're going to graph our two equations. So x squared plus y squared equals 36. Like I said before, that's a circle. It's a circle with a center at 0, 0, because there's no numbers within the squared. And then the radius is 6. Because of that 36, the square root of 36 is 6. So I'm going to go up 6 and all around 6. And I can graph my circle. Hopefully it looks semi like a circle. Kind of. And then I would graph my line. So my line, I already got it in y equals mx plus b when I was solving for y. So my starting point is at 6, and my slope is +1. So if my slope is at +1, I am going to go down 1 over -1. Down, keep going, 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 and I would draw my line. And so my graph looks something like this, and I double check. So 0, 6, yep, it intersects there, and -6, 0, yep, it intersects there. So that does it for number 10. So let's move on to number 11. Okay, so for number 11, we have a circle. The first one's a circle, and then we have a parabola. Now, this parabola is a little different, so we'll kind of talk about that when we get to graphing that one. So I'm going to just start by solving it algebraically. Now, I could actually solve this two ways, substitution or elimination. On my work online, I solved it using substitution. So on this one, I'm actually going to solve it using elimination just to show you both variations. So what I notice is I have a y squared and a negative y squared. So if I add those right off the bat, my y squareds will cancel right away. So x squared will come down, and the 2x, so those can't combine, so x squared plus 2x just comes down, and it equals 8, because then the y's are eliminated. And then I see that I have an x squared, which is always an indicator that, hey, I need to factor or use the quadratic formula, so I need to set the entire equation equal to 0. So I need to move 8 over. And so luckily, this one factors really nicely. So we have x plus 4 times x minus 2 equals 0. I then set each factor equal to 0 and solve for x. X is equal to negative 4. And x is equal to 2. And so at this point, I can plug these back in to get my ordered pairs. So I have a few things that I can do. I can plug it into either one. I'm actually going to plug it into the top one. It seems a little bit easier. So negative 4 squared plus y squared equals 16. So first starting off with x is equal to negative 4. So 16 plus y squared equals 16. Subtract 16 from both sides, and I get y squared equals 0. So we square root, and of course y is 0. So we get negative 4 for my x, and y is 0. Now for when x is equal to 2, we just do the same thing. So 2 squared plus y squared equals 16. So 2 squared is 4. Subtract 4 from both sides, and I get y squared is equal to 12. And so then I would take the square root of both sides to get y equals plus or minus 2 rad 3. And so my ordered pair, which is actually 2 points, is 2 plus or minus 2 rad 3. And so there are my two answers. You can totally write these as 3, right? So this one and then these 2. Or you can write it as 1, that's totally fine. Now, I'm going to just first start by graphing my circle. I'm going to graph my circle in a little bit different color so at least you see the difference. Again, my center is at 0, 0. And my radius is at the square root of 16. So my radius is 4. And so I start just by graphing. Okay, now with the parabola, what I'm going to do is, if it's like totally screwing you up because the y is squared, where typically the x is squared. So that just means that it's this where it's like facing this way, this parabola. You can either think of it kind of like with the conics that we did last chapter, or you can just really easily make an xy table. And so we can just kind of make an xy table and just go from there. So if x is, negative 1, I would plug it in. So that would be negative 2. Add negative 2 to get negative 6. Divide both sides by negative 6. And you have a number. You get positive 6 square root. And so you'd have plus or minus rad 6. With like 0, you can plug in 0. I could plug in 1. I could plug in 2 and negative 2 and just get those points. On the test, you're not going to have one that's this hard to graph. I recognize that too late, and so I apologize for this one being a little bit difficult to graph. So with this, it would be 0, and then it would be, y squared equals 8, so it would be plus or minus rad 8. But what actually helps is looking at the 2's, and we know it intersects here. And so I'm just going to graph it because I've already graphed it and I know how to graph it. So it would be -2 and 2. And then my other points would be 4 and 4 and 4 and -4. And so I have my sideways facing parabola. So like I said, I know this one was kind of more difficult to graph, but you can always either do an XY table or you can use the conics with parabolas. But you're not going to have one, like I said, that's a sideways facing parabola, so you don't have to worry about that. If it was a regular parabola, all you have to know is how to shift it up and down. Okay, so that does it for number 11. I'm going to pause it here and continue on with the inequalities on the next video.